In this video lesson, what we're going to do is take a look at creating all of the graphics functionality needed for our level editor.
Right, so we can basically see what we did in the last lesson.
That's right. Hence the name of this particular lesson, the GUI Functionality, Part 2, the graphics core.
Sounds so fancy.
It sure does. Though functionality-wise, besides an on-size and on-paint, I can't think of anything we're going to add in regards to functionality in the GUI itself. It's really just setting up the graphics core, almost like the graphics engine, if you will. I mean, with a level editor, you need to be able to see what your level is going to look like, because that's the whole idea of designing the level. You draw your walls out, you add your player and your enemy spawn points, and you see where they are at. And so we're going to implement, back buffers, final back buffers, etc.
Yep.
We're going to be dealing with the on-paint and on-size functions, just like we had set up over in Evil Monkeys. As a matter of fact, we're going to be copying the flip back buffer and the stretch game view code, since it's so similar to what's needed here in the level editor from Evil Monkeys over to here.
Right.
So, Joey, if you want to just quickly walk through our three objectives there, then we'll jump over and start coding.
And the first step, we're going to create an array called items. Basically, we're just the variables needed for handling graphics. So, like Buzz said, the back buffer and the final back buffer.
But in items, we're going to be holding the four different things.
Right, like the tiles, like the enemy tiles, the player tile, etc.
The wall and the fireball.
Exactly. Well, not
the fireball. I was just testing to see if you were still with me.
Sure. And the next step, we're just going to create the functions in the header, just prototype them out. So we have the on-size, on paint, update view, flip back buffer, and stretch game view. And then finally, we'll just implement them. And these last two right here, we're going to copy and paste them from our Evil Monkeys and just make a few little changes, and then everything should work fine.
Right. Now, as with the other lessons that we've done, this one is relatively involved. We've got a lot of code to add. So as we've said before, sit back, relax, grab some coffee or something, and
just to be set.
That's right. You'll be set. Just bear with us.
That's right.
And we're just going to relax and chill out.
Yeah, we're going to chill out, be groovy.
All right, let's switch over to .NET.
So let's switch back over into .NET. And we start out in our header file here, and let's go ahead and create the functions that we need here. So, or actually, let's create the variables first.
Yeah, sounds good. So we'll start out with our WX bitmaps.
Yeah, let's go ahead and
bitmap.
Just really quickly, just kind of comment these two sections as our controls, just as a quick way to separate it. And right here, what we're going to do is create our WX bitmap for our items, which is going to be an array.
That's right, which can hold 4 things.
Yep, it's going to hold 4 items. And we're also going to create, of course, the back buffer, so a pointer to the back buffer.
So another, of course, WX bitmap, and yet another one for the final back buffer.
Well, final back buffer. Okay.
Well, that was easy. That was the first step.
Yep, the first step is now completed. So actually, let's look at that so we can feel accomplishment. Ooh, that's the first one. Yay.
Done.
So the second step is to create the different functions that we need for this. And for the event handlers, we have void on size. And it's going to be a WX size event, so WX size event and event. And then, of course, we have our on paint event. That's going to be a paint event.
Cool.
So simple as that. And we also need to create our prototypes for our update view, flip back buffer, and stretch game view. So in the private section here, let's go ahead and say void update view. And we have our void flip back buffer.
And the void stretch game view.
Right. Void. I can do it. Okay, so there we have it.
Cool.
Now with that set up, let's go back over into appframe.cpp and start actually implementing these functions. But before we do that, in the very top, remember we always initialize the variables that we have. So let's go ahead and initialize final back buffer and regular buffer equal to null. So let's set back buffer and final back buffer equal to null.
Okay.
And before we go any further, let's also go to our game window and make sure that the events are captured.
Yeah, let's go ahead and do the dynamic event handling here.
So let's take our game window.
Little connect action.
So, and we're going to connect. And we'll just set these.
-1 and -1, yeah, because that's cool.
And then the event that we're handling is going to be the size event. And of course we have our big long WX object event function, which is going to cast the function that we pass to it, our app frame on size. And of course we have to pass it the null into this so that it calls the right function. And let's just copy and paste this so that we can do the same thing for our paint event. And we'll just change this to WX EVT underscore paint. And change this to on paint. So that covers handling the events. Now let's go ahead and get our items prepared so that we can have this to print when in our update view.
Right.
So let's go down to the bottom here, and right after our toolbar is realized, let's go ahead and create the images that we need. As you remember from up here, when we created the images, we stretched them down to 16 by 16. In this case, we're going to need them to be 32 by 32, so it can look just like it does inside the game. So we'll say our wall image is going to equal our WX bitmap, and after doing this first one, we'll just go ahead and copy them. But we're going to need to convert it to an image, and in fact, because we know that these are all 32 by 32, we can directly just load it into the image, and it should be all set. Oh, except for one little thing. We need to convert it to an image so that we can set the mask. Exactly.
Right.
So let's just do wall image dot set mask. And for this one, we just want to ensure that the mask is set to false, so that it doesn't draw some transparent background image. And we'll set all bitmap equal to, and just cast this over to a bitmap, the wall image. And we'll do the same thing for the player. So we copy and paste this. And
the only real thing, of course, is now we're going to be setting a mask color.
Yep. And we'll convert it to an image, and instead of set mask false, we'll just do set mask color. And we want it to be white. And then finally here, just set player image, and let me make sure, well, player bitmap equal to player image.
Perfect.
And let's go ahead and copy this for our enemy as well. So we have our enemy image equal to enemy tile, and we convert it to an image. And then we have our enemy image, that's MS color. And finally our enemy bitmap equal to enemy image.
Okay. And now in the next section, what we can do is go ahead and bring our items array into play here.
Right.
And let's go ahead and populate items 0, 1, 2, and 3 with our different bitmaps here.
Right. In this case, empty tile we haven't really loaded yet.
No, we haven't. So
what we could do is just come in here just to make it a little bit more clean. We can just create another bitmap, and we can call this let's say empty tile, empty bitmap. Okay. And then we'll just equate this to WX bitmap, and we'll call this WX bitmap, just converting it over. And it's going to be our empty tile, and we'll convert it to an image. Actually, for this one as well, let's go over into our resource view just so you guys can remember what it looked like. Check this over here, and remember our empty tile. And if we go to View, Properties window, this is going to be 32 by 32 as well. So we're all set. We don't need to really.
So we don't need to scale or anything like that.
Yeah, exactly. So let's come over to here. Just grab this, directly slap it in there. And for this one as well, we do not need to set the mask color because we know what it is.
Right. So at this point, we can really just drop in empty bitmap.
Yep.
Yeah. And then for items 1, we'll drop in wall bitmap,
which we created just above.
Items 2 will drop in player bitmap. And finally, items 3 will drop in enemy bitmap.
Enemy bitmap.
Very nice.
So there we have it. Now we have the items necessary so that when in our update view we can actually update our tiles. So let's go ahead and create the let's see, just real quick, let's switch back over into context so we can get a focus of what we want to do here. Let's set up our onSize and onPaint functions so that we can get all that ready.
Okay.
Remember, onSize is going to make sure that final back buffer is always the right size. That's very, very important. So let's go ahead and create that. Go back to our .NET here. And let's switch down to a place that seems logical to put our onSize event. So let's put it right here under void app frame onSize.
We'll start out by, of course, doing an event.skip.
Right, just so that it does whatever it needed to do before. And so it calls the default function.
Right, now we'll go ahead and check to see if there's a final back buffer, and if there is, we'll go ahead and delete that one out.
Yep.
Okay, now we need to get a client area, a size basically. So WX size, client area equals game window, get client size. And now we can go ahead and create the new final back buffer.
That's right. So let's just create it. So we have our final back buffer. It's going to equal a new WX bitmap, and it's going to equal the client area dot get width. and the client area.getHeight.
And we're not really going into depth in regards to explaining stuff at the moment because, I mean,
we just did
this. Yeah.
I mean, we did exactly the same thing.
Over in Evil Monkeys.
Yeah, so there's not really much point in explaining it all over again.
It's the exact same thing.
So if a back buffer does not exist at this time, let's see. We're going to go ahead and just draw a rectangle around this area. So, does that make sense?
Sure.
So we're going to, if the back buffer does not exist, go ahead and just draw onto the screen. So create a DC of our screen DC. So grab the DC of our game window. And since we already have the client area, let's just go ahead and do a screen DC.clear. And do a screen DC.draw rectangle. And from 0, 0 to client area.getWidth and getHeight. So client area.getWidth. Let me just copy this up here, just to kind of save a little bit of time, or at least give my fingers a chance to kind of rest for a second.
Yeah.
Otherwise, if it does exist, we're going to simply stretch the game view and flip the back buffer. So stretch game view and flip the back buffer.
And we'll get to those in just a minute.
Right. And real quick, let's go ahead and implement the onPaint function, which is really, really simple. We just do our void appFrame. Actually, the hardest part is just declaring this part right here, which is a nice thing. So we have our paint event, and we have a reference to it. And this is going to be, remember, we have to use a paint DC for an onPaint function. Grab the this, which in this case, since the game window is capturing it, this is going to be the game window, so that's all good. We don't need to prepare the DC, and just stretch the game view, and that's all there is to it, just like we did back in Evil Monkeys. So flip the back buffer, and we're done.
Cool.
So now we have the two major functions. If we come back into context, you'll notice that these two have been created. We have update view and these two functions to do. So let's go ahead and first do the update view, and then we'll go ahead and copy and paste those other two guys in here.
Okay, that sounds good.
So let's go back into .NET, and right here, let's do a void, void. Do our appFrame, and this is going to be our update view. And let's first make sure that the back buffer does indeed exist. If it doesn't, then we're just going to return so that we don't continue the function, have something go terribly wrong.
Right.
And then let's create our back buffer DC. So let's do a WX memory DC for our back buffer so we can actually start drawing to the back buffer. And we're going to select the back buffer. So let's go ahead and say back buffer DC dot select object. And remember, the back buffer is where we're going to draw everything. The final back buffer simply has the stretched version of the back buffer. And then we're just going to clear. First, we're going to set the background.
Yeah, we're going to go ahead and set it to the color black.
And we're just going to do a WX black brush. And just let's copy this so we don't have to type. Whoa, no. Dot clear. And then let's go ahead and create the actual lines inside of our for our grid.
Okay.
So the first thing we're going to do is set the pen to a light gray. Remember, in our grid was light gray.
Right.
So let's go ahead and do our back buffer dot set pen, and it's going to have a pen color. We're just going to create another WX pen because remember, set pen is looking for pointer to a pen object, and it's going to be of color 128, 128, 128, which is a light gray.
Right.
So with that set, all we need to do is draw lines all over this thing. So we're going to draw lines all the way down the x-axis and the y-axis. So we're going to have two loops here, one that draws the vertical lines and one that draws the horizontal lines. So int x equals 0, and while x is less than the current level, because remember, current level holds the current level.
Yeah, I was going to say that's the current real level.
Right, and it holds the width and height of our level. So current level, while it's
grid X,
and then we just plus.
Yeah.
And all we're going to do here is say back buffer DC dot draw line, and basically we're going to draw since these are the vertical lines. If you look at it, this actually let me just go back over into here real quick. I would just exit this and just go up to where we have our files located. And if we go into our level editor here, just give it a second, and let me just create a new package, 10 by 10, and you can see that we have the vertical lines going down.
Right.
So basically our x is going to go like this, so we're going to have the x is going to stay the same for the first component, and y is going to start from 0 and go to the very base of our client size, basically. So let's exit that out, just so you guys can see how it works. And we're going to draw a line. So we're going to create a point. So x is going to be x multiplied by grid underscore size plus 1. And if you think I need to explain more, just say so. And y is going to be 0 for the top.
Right.
So that's the first point. The second point is going to be at the exact same x location, and y is going to be moved down to the bottom.
All the way down to how far it goes.
Right. And this is going to go all the way down to, remember, we have our current level, which stores how high our level is.
In grid y.
And again, we're going to multiply by our grid underscore size plus 1. Okay, so let me just kind of overview.
Did we define a grid size yet in this?
Actually, you're right. We do need to go to the top, and I do not think we defined our grid size.
Either.
So let's just go and define our grid size as 32, of course.
Yeah, just to be safe.
Right.
Well, not just to be safe, because we have to.
And it's kind of important. So let's go back to where we were, our update view here. And you'll notice that the x is simply the current grid that we're on, and it's the same for both points. The first point is going to start out at 0 for y, and the last one's just going to go to the very bottom.
Right. So there's your line from top to bottom. And of course, the grid size plus 1 is because it's 0 based.
Yeah. So let's just copy this entire thing, because we're going to be doing a fairly similar thing for the horizontal lines. Let's change this to y equals 0, y is less than grid y, and y plus plus.
Cool.
Now, instead of having this one as grid x times grid x or whatever, the first one's going to start out at 0, because these are horizontal lines.
That's right.
And this is going to be y times grid size. So we're just flipping it around. And for this one, of course, we're going to start out, instead of here, let's just take this, move this over, and we want to be at the very end of our level, so grid x times grid size plus 1. And then, if I could just see where this is at, then we just do y times grid size
plus
1. And I think I need one more parenthesis there, and we should be done.
Okay.
So a little bit confusing, a little bit long, but it's not really that complicated when you think about it. So from there, we have the horizontal lines. Let's go ahead and set it so that we can draw the bitmaps that we need for the entire level. So we're going to do an entire loop through all of the different data cells of the current level. So we say int x equals 0, x is less than, and this is much the same as when we drew the level for our evil monkey. So there's a lot of similarities to these two. So the inside loop is going to say y equals 0, y is less than current level, grid underscore y, y plus plus. And then what we're going to do is kind of just set this up here. So let's do, we want to make sure that each of the grid items, because remember, let me just kind of recap a little bit before I say all this. We have our item, we have our grid cell, right? So we want to get the data value that is in the grid cell xy, right?
Right.
So let's declare a local integer item, and we're going to equate that to the current level's grid at x and y. So this holds an index, basically, into our items array.
Right.
And we want to draw the bitmap at that element of the bitmap. So let's make sure that whatever item is in there is greater than or equal to 0 and less than or equal to 3. So that we make sure we don't draw some random variable.
Well, that's all we have that's being populated inside our
we only have
items array.
We only have 4 elements, so we don't want to exceed that. So let's just do a back buffer dc.draw bitmap. And first thing I'm going to do is draw the background. This is basically used because we want to make sure we clear the background first with our background tile and then draw onto it.
Yeah.
Just in case we have, say, like the player tile that has a mask on it and we don't want the background to be black.
Right. We're going to be able to see the floor behind the character.
That's right. So this is going to be x times grid underscore size, just setting the location, and we're going to have plus 1 for this guy. And exactly the same for this one. Y times grid underscore size plus 1. And just close that off. And then, instead of drawing the background, draw on the exact same location, but with index item.
Right.
So, also we need to make sure that we include the mask as well, because we don't want to forget that.
That's right.
So with that,
And did we put the mask on both or just one?
we'll just do that for the one, because the background won't have a mask.
Yeah.
So of course now we need to just kind of remove the back buffer from being associated with the DC.
So we don't have any problems. Memory leaks.
Memory leaks are bad.
Yes.
Although there are very cool plugins to help you prevent them.
Then we can simply stretch the game view and flip the back buffer. Woo!
Yay. Oh, flip game view. Flip back buffer.
Yeah, and take a look at, there we go.
So, very close here. Now we just need to, create the flip back buffer function and the stretch game view. And like I said, we're going to actually use our game view.
We're going to use pretty much the same code for our flip back buffer and for our stretch game view from the Evil Monkeys game that we've written previously.
Thank you.
You're welcome, sir.
Now let's basically load that item in here. So if I just go up here, I have the Evil Monkeys code here as well. So let me just load up appframe.cpp from Evil Monkeys, just so I can look at the old code.
Okay.
So let's just scroll down to where we created these two. As you can see, we have our stretch game view right here, which does all of that. And we also have our flip back buffer. So let's just take all of this code, copy it, go over to our new appframe.cpp,
right,
and just paste it down here. So paste this in here. Now let's make sure that there aren't any major changes that we need to make. So in flip back buffer, just as a quick recap, we get the client area. We set the client DC to game window, we blit it onto the location, and then make sure we clear it, so everything is fine.
Cool.
Now, if we go back up to our stretch game view, everything should be almost exactly the same. We get the client area, we create the stretch size, but there's only one thing that's going to change for every single one of these. Instead of level now, we have current level.
Right.
So let's change all of these to current level. In fact, there's an easier way we can do this. If we just press Control F for a find, we also have a replace functionality. So we can just say replace all of level with an arrow to all of current level with an arrow. So if we just come up to here and make sure we match whole word. So it replaces this, replace that, replace that. So, and then we're done.
Cool.
So otherwise, everything should be pretty much right. So let's go ahead and compile this and see the mass quantity of errors that Buzz missed.
Well, just because you said that, now we got this tremendously long list.
Yes, of course. Now I put VO'd again because VO'd is my friend. Okay, flip back buffer identifier not found, even with argument independent lookup. No worries. What we're going to do is come over to our header file here. Of course, I capitalized the B instead of having it lowercase, so it's going to have all sorts of issues here. And get height. Remember, I just changed all of these to current level. But if you look back up here, remember that we have grid X and grid Y. We no longer have get height and get width.
Right.
So let's just do a manual replace of these. So this is supposed to be grid underscore Y. And let's just copy this. And anywhere where it says height for our current level, we just are going to replace it with grid Y. So grid Y here, and this guy right here is supposed to be grid underscore X. So let's just copy him right here. Go to our current level, get width, modify that, and modify this guy right here. And we should be pretty much set. So at least that should minimize most of our errors. So almost there. Flip back buffer is not a member. This needs to be a capital B. And actually, I think that should
clean it all up.
Yeah, I think so.
There you go.
There we go. So with that, hopefully we have everything set up correctly. Let's do a quick test run, make sure that if it locks or anything, we know that something must have gone wrong.
Right.
So if we run this, clearly something definitely went wrong. The first thing to always do, if something like this happens, go ahead and rebuild your solution, because there are times when the linking and everything is a little bit different. So let's go ahead and rebuild it to make sure something isn't totally screwy. Let's go ahead and play this. And yeah, there's something definitely wrong here. So let's go back and make sure that everything is set up properly. So we have our final back buffer, our back buffer, and let's go down here, make sure that everything is being created properly here. Dun dun. So we have our empty bitmap. We know that this must be near the beginning because it's kind of dying on us very quickly.
Real quickly, yeah.
So let's see. Make sure that this is correct. Stretch game view on.
Wait.
Yeah.
Go back up some.
Well, this is okay.
Okay.
Well, it doesn't absolutely need to have this return here, so let's just get rid of it. Let's see. WX Paint DC, stretch game view. So we do have. Okay. Let's go back to our. Just 1 second here. Make sure that we implement every function we need inside of our that we set up here. So as you can see, we have our onSize that we definitely implemented. We have our onPaint. We have our update view. We do have our flip back buffer, and we do have our stretch game view. So we have accomplished pretty much everything that we need to accomplish here.
Okay.
So let's go back and try to troubleshoot here and figure out.
Definitely something's wrong.
Something's definitely wrong. We didn't forget to implement something.
Right.
So let's see. We have all of that. Let's go back down to our onPaint event and make sure that guy is set, because that's kind of where I feel some sort of problem is at. So we have our WX Paint. Yeah, right here. Remember, we're pointing it to. We're trying to redraw our game window, right? So that's where we're trying to change. So it's not this, which is our app frame. We want to change this to our game window.
Okay, that makes sense.
And we also want to change it so that to make sure that our back buffer is already in existence before we go drawing the game view and everything. So let's change this to make sure that we already have a back buffer before we go and do this. And another thing, in our onSize event, just kind of somehow I accidentally, sorry guys, copied the wrong code to here. So let me just cut this guy out, and of course, did it again. Let me just kind of cut this right here with Control X, and this is in the onSize event. So let's delete that out and just kind of clean this up a little bit. So remember, if the back buffer exists, we want to stretch game view, and back in the paint event here, we want to make sure that it actually prints out the black border that we wanted to begin with, and that would mean that there is no package created, no levels created. We just want to draw a simple black border. So here, what we're going to do is say, if not back buffer. So if a back buffer hasn't been created yet, we want to draw that. Otherwise, we'll simply stretch the game view and flip the back buffer. Does that make sense?
Okay, yeah, because obviously there's a back buffer.
Right. So let's just clean that up a bit. And one other thing that I'm pretty sure I probably forgot is under the set current level. So if we just search for set current level, under this function, yeah, I did forget to put this in as well. We have the set current level. Right inside of here, we need to make sure that our back buffer is created with the new size of our level.
Okay.
So let's create our back buffer. So back buffer equals new WX bitmap, and it's going to be the size of our level, grid X, multiplied by grid underscore size plus 1, because it is 0 based. I'm going to just add 1 to that, and our current level, grid Y, multiplied by grid underscore size plus 1 plus 1. So there we are.
Okay.
So if we compile this, we should hopefully fix the little problem that we had there, except for one small thing here. Our client area, remember...
We need to grab that from above.
Yeah, well, let's just grab this from above, and from the onSize event, and put this into the paint event, and recompile. That should be everything.
Right. So it knows what the client area is.
Yeah. So if we run this, we do get our border, because that means before we have created our actual level. And let's go to New Package. And right now, it's not being updated. Why is that? Well, because after we create the new level and set the current level, we need to update the view.
Right.
So
that makes sense.
So let's exit this out and go to our set current level function again. And of course, we might as well just search for this again. So right under here, let's update our view.
So we've just set the current level. Now we need to update
the view. Right.
Makes sense.
So if we create a new package, it sets the level, and that's almost everything except our horizontal lines are being kind of
look a little
funky.
Funny, yeah.
Yeah. So let's exit this out, and go to where we draw, which would be the update view. And let's just go to the update view. And remember, we're drawing the horizontal lines, the vertical lines, and then the horizontal lines. So something with this is causing this to screw up. Well, let's see. Right here, we do need a +1. So we'll see what that does. Just one.
Okay.
And we'll just create a new package here. That wasn't exactly what we're looking for. So let's see. It starts at 0, 0, from 0 and y times grid size +1. That seems right. And then it's going to go across to grid size times grid size +1 +1. That's right. And let's see here. Trying to think if there's anything else that we failed to do. And I'm not seeing it. Let's go ahead and just introduce a little bit of debugging like we did in the previous lesson. And when we get to here, our y is going to be equal to 0. And we want to print grid size +1. So this entire thing should equal grid size +1 times 0 should equal 0. And this same thing for over here. And this should go all the way across. Oh, I do think I see what's going on here. Let me stop the debugging. I think I had a bit of inspiration here, if you will. Let me just exit, delete that, cut it, and paste it on the bottom here so that this guy right here isn't drawing over it. So let me just
item
this.
0.
Right, because that is sort of overlapping our grid. So if we run this,
bingo,
and then that fixes it.
That does it.
So now we have almost everything we need.
Yeah, re-show them why you cut and move that. Cut and paste that, so you move the...
Alright, so let me just exit this
lines.
out. Right, so before I put the line code right above our draw bitmap here...
Well, we were drawing out item 0 and then your other items.
Right, and then I did that before. Now I removed it and put the line drawing code right below
so your
that.
horizontal lines were being drawn over.
Yeah.
Makes sense, yes.
So if we just look back in context, again, just to kind of put things back into focus, we've created all these functions, and now that is the graphical element. Now what we need to do is pretty much add the elements where we can paint the elements in, the wall, the enemies, and the player start.
Right, and we're going to do that in the next lesson.
Yep.
And with that, that's going to wrap up this lesson. Thank you very much.